Now let's move to this question. Okay, so here let capital N be the coefficient of x to the power 2025 in the expansion of the following term: x plus 1 times x squared plus 3 times x to the power 4 plus 5 all the way till x to the power 1024 plus 21. Now what is the remainder when n is divided by 100? That's what we're asking. Again, the final part is the easy one. Calculating the remainder of any number when it's divided by 100 is a easy one. So most of our effort will go on calculating the value of n. Okay. So first let's try to make sense of this term. Can you see a pattern here? There is a pattern. If you look at the power of x, we have x to the power 1, then x to the power 2, x to the power 4, x to the power 8, all the way till x to the power 1024. So it's very intuitive. These are all the powers of 2, because 2 to the power 1, okay, 2 to the power 0 is 1, 2 to the power 1 is 2, 2 to the power 2 is 4, 2 to the power 3 is 8, all the way to 2 to the power 10 is 1024. So we found out that pattern, and we also figured out that there are a total of 10 terms in this expression. Now what about the constants? Do they have some pattern? Actually they do. We have 1 plus 3 plus 5, okay, 1, 3, 5, 7 all the way till 21. Does it look similar? So it's like 0 plus 1, 2 plus 1 equals to 3, 4 plus 1, 6 plus 1 equals to 7, and so on. So what it's happening here is that 2 times 0 plus 1 equals to 2, 2 times 1 plus 1 equals to 3, sorry, this is 1, again 2 times 2 plus 1 equals to 5. So we have this pattern here for the constant. So actually you can combine both of them and write a general expression for all the terms. We can write it as x to the power 2 to the power n plus 2 times n plus 1. So just plugging from n equals to 0 to n equals to 10. Okay, sorry, there isn't actually 10 terms here, there are 11 terms. So previously I said 10, that was my mistake. There are actually 11 terms here from 0 to 10. So we have figured this part out as well. Now to explain the logic of this x to the power 2025. Again we know that when you multiply two terms with the same base, the product is x to the power a plus b. So this concept will be used here. Okay, now before we proceed further, I want to start with a smaller example to help you understand the logic behind what's going on. Suppose instead of this 11 terms, we have only this 4 terms. Okay, and so let me write it down first. So we have these 4 terms: x plus 1, x squared plus 3, x to the power 4 plus 5, and x to the power 8 plus 7. So remember, I'm now solving a completely different problem, not this, a very small problem and a different problem, to help you with the intuition. And once you're done with that, we'll come back to this problem. So this is a different problem now. So we have these 4 terms, and I want you to figure out what's the coefficient of x to the power 12. N, where n is the coefficient of x to the power 12. What is it? So first of all, how do we get x to the power 12? That's only going to happen when x to the power 4 and x to the power 8 are multiplied. So if you multiply these 2 terms, we get x to the 4 times x to the power 8 plus x to the power 4 times 7 plus 5 times x to the power 8 plus 5 times 7, and we have these 2 terms, x plus 1 and x squared plus 3. So this becomes x to the power 12 plus x, so okay, 7 times x to the power 4, 5 times x to the power 8 plus 35, and x plus 1 and x squared plus 3. So far, what's the coefficient of n? 1. But we have not fully expanded this. This term will have to be multiplied by these 2 terms that's still remaining. Now think of it. When you multiply this term with this term, what will happen? Which term will only have x to the power 12? Only when this term multiplies with this term. Otherwise, any other multiplication will not create x to the power 12. Okay, you want to see that? Let's do it. We're going to multiply these terms, this whole term, with this. So it's going to be very lengthy and look very cumbersome, but I want to do it still so that you understand the logic. Okay, so x to the power 12 plus x, okay, power 12 into x plus x to the power 12 into 1. Okay, now we move on to the second term, 7x to the power 4 times x plus 7x to the power 4 times 1. Then we move to the third term, 5x to the power 8 times x plus 5x to the power 8 times 1. Then move to the final part, 35 times x and 35 times 1. So if you simplify this, this becomes x to the power 13, x to the power 12 times 1 is x to the power 12, then x to the power 5, then 7x to the power 4, then 5x to the power 9, then 5x to the power 8, 35x plus 35. So you see here only one term. And what's the coefficient here? So technically, okay, let me make one change here. Let this be 2. Okay, x plus 2. This is going to be 2 and this is going to be 2. Okay, so let me redo this whole thing again, because now it will make more sense. So x again. Okay, I'm simply going to redo this thing again so you know the logic. Okay, if you simplify this, we get this. Okay, now what has happened? So only one term still has x to the power 12, this one. And what's its coefficient? This one, 2, the constant term of this one. Okay, now again one more term is still remaining, x square plus 3. So what's going to happen? How is x to the power 12's coefficient going to change when you multiply by this? So let me show you and then tell you the shortcut. You don't have to, when is now go. So when we will try to solve this for 11 terms, we're not going to manually multiply all 11 terms, because we're going to find a pattern eventually, and I'm going to show you by telling you. Again, this is going to be lengthy enough, but for the sake of it I have to do it. Only then you'll get the logic once and for all. There will be no ambiguity. So first term with this and this, then again second term with this and this. So okay, let's do this. X to the power 13 times x square plus x to the power 13 times 13. Then moving on to x to the power 12, 2 x to the power 12 times x square plus 2 x to the power 12 times 3. Then again 7x to the power 5 times x square plus 7x to the power 5 times 3 plus 14x to the power 4 times x square plus 14x to the power 4 times 3. Then 5x to the power 9 times x square plus 5x to the power 9 times 3 plus 10x to the power 8 times x square plus 10x to the power 8 times 3 plus 35x 3 times x square plus 35x into 3 plus 70 times x square plus 70 times 3. So there are a lot of terms here. Actually there are 1 2 3 4 5 6 7 8 16 terms. Okay, so let's simplify, and again you'll see, and then we'll focus on the constant term with x to the power 12. So this, the first term becomes x to the power 13 plus 2 is x to the power 15. Second term is 13 x to the power 13. Third term is 2 times x to the power 14. Fourth term is 6 times x to the power 12. Fifth term is 7x to the power 7. Sixth term is 21 x to the power 5. Seventh term is 14 x to the power 6. Eighth term is 14 times 3 is 42 x to the power 4. What term is it? Ninth? Yes, I think so. Yes, ninth. Ninth term is 5 x to the power 11. 10th term is 15 x to the power 9. 11th term is 10 x to the power 10. 12th term is 30 x to the power 8. 14th term is 35 x cube. Actually I think it's the 13th term, this has to be 14th. term is 35 into 3 is what is it, 120, 135, is it? Sorry, 105x. Then we have 70, 15 term is 70x square, and this final term is 16 term is 210. So which term has 6 to the power 12? Only one, this term. No other term has 6 to the power 12. And what's the coefficient of 6 to the power 12? It's 6. So we spend, I think, about 10 minutes coming up with this, which is on. Now remember that we were only working with 4 terms. Now if we have to repeat the same operation for 11 terms, it's going to take a long time. But we do not have to do that, because there is actually a pattern. Notice. So you can notice here, what's the coefficient is 6. Now just take a look here. Once we find x to the power 12 by multiplying this term and this term, what are the other remaining terms? This and this. And look at the constants of these two remaining terms, which are 2 and 3. Now if we multiply the constant of these two remaining terms, what we get? 3 into 2 equals to 6, which is the same as this 6. So instead of going through all this hectic process, what we can do is we just find out the terms, the polynomials, which do not form x to the power 12, and then we multiply the constants of those polynomials, and we get this number 6. So that's the exact strategy we are going to use here as well. So what I have to find here is x to the power 2025. So we'll figure out which of the polynomials out of these 11 polynomials are used to form 2025, and the polynomials that are remaining, we'll take the constant and multiply all the constants, and whatever value we get, that's going to be the n value of this, that's going to be the constant of this term. So that's the strategy to find n. So first let's focus on which terms will contribute towards creating x to the power 2025. So let's move on here. X to the power 2025. So here what's going to happen is the first term, and also remember that the terms that we are going to use here is going to be from x to the power 0 till x to the power 10. So all of them will be powers of 2. So let me just explicitly write all of them down so that there is no confusion. This will be 1, 2, 4, 8, 16, 32, 64, 128, 512. Did I miss something? Yeah. X to the power 8 is 256, then 512, then 1024. So we have to come up with 2025 by some combination of these 11 numbers. So let's start. So 2025 is equal to 1024 plus some term x. So x equals to 2025 minus 1024, which comes out to be 1001. Okay, so again we have to come up with now 1001 in terms of some of these numbers. So we already used 1024, so we'll cross this out. Now let's focus on 1001. We can create 1001 by 512. plus some other number. So this gives that number is equals to 1001 minus 512. If we take, we get 489. Yes. Again, we use 512, so we'll remove this. Now let's focus on 489. 489 can be created using 256 plus some other term. So this other term is 489 minus 256, 332. I think so. This should be the answer. Let me verify. Yes, 233 is the answer. Okay, now again we'll have to break down 233 as one of those numbers. So again use 256. 233 written is 128 plus some other term. So that term is equals to 233 minus 128, which is 501. Yes. $105. Again we'll continue. So we can use 128. 105. How can you create 105? 64 plus some number. So this number is 105 minus 64 is going to be 141. And how do we get 41? 32 plus some number, and this number is 41 minus 32 is going to be 9. So we also use 32. Now how can you get 9? It's going to be 8 plus 1 is 9. So we used 8 and we used 1. So all the polynomials containing this are used to create 2025. So what we have figured out here is that x to the power 2025 is equals to x to the power 1024 times x to the power 512, 256, 128, 64, 32, x to the power 8 and x to the power 1. So this 1, 2, 3, 4, 5, 6, 7, 8. So these 8 terms are used. Actually not just these terms. So if you want to know completely, so this whole polynomial was used. Similarly, and so on for all of those polynomials. But our point is that these three polynomials survived. So previously I showed you the general term, which was x to the power 2 to the power n plus 2n plus 1. So what's the polynomial for this that contained x to the power 1? Which is x 2 to the power 1 plus 2 times 1 plus 1. That means x square plus 3. Now for this term we have x 2 to the power 2 plus 2 times 2 plus 1, so which is equals to did I make some mistake here? No, I think it's fine. Yeah, x to the power 4 plus 2 times 2 is 4 plus 1 is 5. And similarly for this, x, actually these numbers are not x, this should have been n. That's what's confusing me. Those are all n. But anyways, which is x 2 to the power 4, 2 into 4 plus 1, which is x to the power 16 plus 8 plus 9. So these terms are remaining. So coming back, we have x square plus 3, x square plus x to the power 4 plus 5, x to the power 16 plus 9 times x to the power 2025 plus all those terms that are there. But as you have seen before, we do not need to care about all of those things. To find the coefficient, when we multiply all this with the remaining 3 polynomials, we just have to take the constant and multiply them. So if you take 3 times 5 times 9, is going to be 15. 15 into 9 is 135. So this is going to be 135 is going to be the coefficient of x to the power 225. So we figured out the value of n is equals to 135, but we also have to remember that this is not the final answer. You have to find the remainder when n is divided by 100. So when you divide 135 by 100, the remainder is nothing but 35. So 35 is our final answer for this one.